Welcome back to the course on soil mechanics. In our last class, we started talking about various physical parameters that we are going to be coming across in our soil mechanics, like void ratio, porosity, water content, degree of saturation, air content, percentage air voids, and we have also seen specific gravity of soil solids. And we have subsequently discussed even about how to determine the water content and specific gravity of soil solids in our lab. Okay, we have certainly talked about the lab tests also for determining the water content in the laboratory, what is present in a given soil, and we have also seen how to determine the specific gravity of soil solids, even in the case of coarse grained soil or in the case of your fine grained soil. So next, to continue our discussion, we'll start talking about your other term, that is unit weight. So where unit weight in general is what we define it as the weight of the material to that of your volume of that particular material. So weight, the ratio of weight to volume is what we define it as here unit weight. In case if we are defining it in terms of the mass per volume, then we define it as your density. Okay. So generally unit weight is denoted by the notation gamma, and whereas your density is denoted by the notation, the term density is denoted by the notation rho. Okay, so density is what we define it as mass per unit volume, and whereas your unit weight is what we define it as weight per unit volume. So the units of your density are represented in terms of tons per meter cube, or kg per meter cube, or gram per centimeter cube, and so on. In case if you are talking about the unit weight, the units of your unit weight are nothing but kilonewton per meter cube or newton per meter cube, and so on. So when it comes to the case of your unit weight, now depending on the condition of the soil, whether the soil is in dry state, whether the soil is in partially saturated state, whether the soil is in fully saturated state. So depending on that, we are going to be using different terms. That is nothing but unit weight of dry soil, unit weight of saturated soil, or unit weight of your partially saturated soil, or otherwise I can also call it as your total unit weight or bulk unit weight. So let us try to understand how to define each of those unit weight terms in the case if the soil is dry, or in the case if the soil is partially saturated or fully saturated. So as we mentioned, so unit weight is nothing but which is defined as the weight of the soil to that of your volume of the soil. It's the ratio of weight to volume of the soil mass. Now, in case if the soil is dry, or let's say if I want to find out what is the dry unit weight, if at all that soil becomes dry, what is going to be the unit weight of that particular soil? Or if at all the soil becomes saturated, what is going to be the unit weight of that soil? So in that way, if I want to determine with regard to a soil, then how do we go on to understand them about how to determine the dry unit weight of the soil? In case if that particular soil is in a dry state, what is its unit weight going to be? In case if the soil is partially saturated, what is its unit weight going to be? In case if that particular soil, what I am looking at is a saturated soil, what is its unit weight going to be? Okay. Now let's start coming with the first one, that is dry unit weight, which is denoted by the notation gamma d. Simply we define or we represent unit weight as gamma, and as the soil is in a dry state, in case if the soil is in a dry state, for which if I want to determine the unit weight, then I'll be indicating it as gamma d. D indicates dry and gamma indicates unit weight. So in dry state condition of the soil, what is the unit weight of that particular soil? So how are we going to write down? In general, unit weight, whether it is dry unit weight or partially saturated unit weight or your fully saturated unit weight condition, unit weight means it's the weight of the soil to that of your volume of the soil. Now, weight of the soil to that of the volume of the soil. Now, when the soil is in dry state, what is the weight of the soil means? Weight of the soil is nothing but it is only the weight of your solid particles, because there is no water present in the void spaces. What is present in the void space is only air. So weight of air is nothing but we said it's negligible. So automatically the weight of that soil which is in dry state is nothing but it is equal to the weight of the solid particles. So that's how we represent your dry unit weight as nothing but weight of solids to that of your total volume of your soil. Okay. So we'll come across these relationships what are given here. We'll try to talk about how to derive those relationships after a couple of minutes. Next, if the soil is a saturated soil in which if I want to determine what is its unit weight, so I am going to be finding it in the similar way as like what we have talked earlier. Okay, unit weight is what we represent it as gamma, and the soil is a saturated soil, so it's a saturated unit weight which I am talking about, which we represent it as gamma sat. Sat indicates it's a saturated. Now, how are we going to write down the saturated unit weight? It's once again the weight of the soil by the volume of the soil. Now, what is the weight of the soil? It is the saturated weight of the soil. When all the voids are filled by water in that soil mass, what is the weight of that particular soil divided by the total volume of that particular soil. So, it's the total weight of the soil when all the voids are filled by water to that of your total volume of that particular soil. That's how we define it as your saturated unit weight. And we'll also come across these relations, whatever are represented here, we'll derive them after a couple of minutes. And having seen what is the way how we represent your dry unit weight or saturated unit weight, in the similar way, we also go on to represent what is called as your bulk unit weight, which we have seen in our previous slides. Okay, so simply whenever you see gamma, or sometimes you will also be represented as gamma B, or sometimes you will also be indicated as gamma T, where gamma T or gamma B is nothing but it is what we call it as the bulk unit weight or the total unit weight, or in turn which we can also understand it as the unit weight of your partially saturated soil. So which we indicate it as the weight of that particular soil which is in partially saturated condition, or in the moist condition, moist in the sense which is not fully saturated, which is a partially saturated soil. So weight of that particular soil in that particular state, what it is existing, to that of your total volume of that particular soil. So this weight, now what we are going to be talking about, includes the weight of solids plus weight of water, which is partially filling the void spaces. So whatever the voids that are filled by water, so how much is the weight of that water which is filling that particular void spaces is nothing but we are representing it as weight of water which is partially filling those void spaces. That unit weight what we are going to be talking about is what we can represent it as your moist unit weight or bulk unit weight, or simply we call it as your total unit weight or partially saturated unit weight of the soil. So having seen in different conditions how to represent your unit weight terms for those respective soils, then let us also go on to understand what is meant by submerged unit weight. So what is meant by submerged? Whenever the soil, what you are looking at, is below the water table position, then such soil is what we call it as submerged soil. I repeat, whenever the soil what we are looking at is below the water table, then that particular soil is immersed inside your water condition. That is what we call it as submerged condition of the soil. And the corresponding unit weight of that particular soil which is in submerged condition is what is represented as gamma sub. Gamma indicates unit weight, and sub here notation indicates it is the submerged condition of the soil for which we are trying to talk about what is meant by your unit weight. So the submerged unit weight of the soil, which is indicated as gamma sub, or which is also otherwise represented as gamma dash, is what is represented as your saturated unit weight of that particular soil minus the unit weight of water. Okay, so what is this saturated unit weight means? Whenever the soil is below the water table position, all the voids are going to be filled by water. So the submerged unit weight of the soil is nothing but it is equal to the saturated unit weight of the soil minus unit weight of water. Why are we subtracting the unit weight of water from your saturated unit weight? Means whenever the soil is in submerged condition, you have the effect of buoyancy acting on that particular soil which is in submerged state. So the buoyancy, your weight of the soil acts in the downward direction, buoyancy force on that soil acts in the upward direction. So the net effect on that particular soil is nothing but it's the saturated weight of the soil minus the buoyancy force, which is in turn we are coming across because of the water which is exerting the force on the soil in the upward direction. So that's the reason why the submerged unit weight is what we write it as your saturated unit weight of the soil minus the unit weight of your water. Now, if I just look at this particular picture, it gives us a clear understanding, like in which case I should talk about which unit weight. Let's say, for example, in this depth, if I am looking in this particular depth, first stretch in this region of the soil, what I understand is that all the voids are filled only by air. Then the corresponding unit weight, when I want to calculate for that condition of the soil, is what I can write it as your dry unit weight of the soil. Whenever the soil is in a dry state, obviously your degree of saturation value is nothing but it is equal to 0. Okay, so when you are talking about the dry condition of the soil, unit weight correspondingly what we represent is nothing but gamma D, and the corresponding degree of saturation value S is nothing but for that soil is equal to 0. Whenever the soil is partially saturated, which means that some void spaces are filled by water, the other remaining void spaces are filled by air. So in such particular case, the unit weight, what we call it as, is nothing but it is your bulk unit weight or total unit weight or partially saturated unit weight of the soil. So in such particular case, your degree of saturation value obviously varies in between 0 to 1 as the soil is partially saturated. And when the soil is said to be fully saturated, whenever all the voids are filled by your water, then that particular soil is called as your fully saturated soil. The soil which is existing in this region is what I am calling it as your fully saturated soil. And for that fully saturated soil, the unit weight what we represent is nothing but we represent it as your gamma sat. Sat indicates the saturated. Whenever the soil is in saturated condition, the corresponding unit weight what we are going to be looking at is what we indicate it as gamma sat. And the degree of saturation when the soil is fully saturated is nothing but it is equal to 1. And if you look at here, in this depth of the soil strata, whatever we have corresponding to this region, okay, it is that portion of the soil is there below the water table. Whenever we say that portion of the soil is there below the water table, then that depth of the soil strata, let's say it's a h meters depth of the soil strata, which is there below the water table position. We are saying that this is my water table position, which indicates that the soil below that is in a submerged condition. Okay, whenever the soil is in submerged condition, then the corresponding unit weight what we represent is nothing but it is indicated as gamma sub, or otherwise we also represent it as gamma dash. Okay, how are we writing down the submerged unit weight? Submerged unit weight is nothing but saturated unit weight of the soil minus the unit weight of water. So whenever the soil is in submerged state also, all the voids are filled by water, and the corresponding degree of saturation is nothing but it is equal to 1. Now, having understood about various physical parameters with regard to the soil, like void ratio, porosity, various other parameters like your specific gravity of soil solids and unit weight terms, let's go on to understand how to derive some of the basic relationships between these various parameters what we have come across with. Okay, so let me start with to see how I can derive a relationship. Okay, how to derive a relationship between void ratio, water content, maybe degree of saturation, and specific gravity of soil solids. Let's say I wanted to understand how to derive a relationship between these physical parameters with regard to a soil. Now, why these relationships are important? Because whenever you are looking at a particular soil, you might be knowing only some information with regard to that soil, and some other information may not be known. Like say, void ratio of the soil is known, water content present in that soil is known, degree of saturation value of the soil is known, but you don't know about what is the specific gravity of soil solids of that particular soil. So based on the data what is known, you can go on to find out the unknown parameter with regard to that particular soil. If you know what are the basic relations that you have got between various parameters, between known parameters to that of unknown parameter, if you have some relations available, then making use of those relations, you can go on to find out the unknown values with regard to that particular soil. So let's see how to derive some of those basic relations which will be coming across. Here we are not going to be deriving all those relations that we are going to be coming across. Just to give you an idea, like some couple of relations, we'll see how to derive them. Okay, I just wanted to derive a relationship between these terms. That's a void ratio, water content, degree of saturation, and specific gravity of soil solids. So for deriving it, let's say I'll start with my fundamentals. That is, with what is meant by degree of saturation. So how do we define degree of saturation? S indicates degree of saturation. So how do we define this degree of saturation? Degree of saturation is nothing but we define it as the ratio of volume of water to that of volume of voids. So within the volume of voids, how much is the volume occupied by your water? That ratio is what we define it as your degree of saturation. So now what I'll try to do is the numerator I'll divide it with volume of solids, as well as the denominator also I'll try to divide it with your volume of solids. So I'm not doing anything. I'm not changing the expression. So I just divided numerator and denominator with the volume of solids. Now in the process, I'm just trying to rewrite my terms according to my convenience and the requirement. Okay. So where I'm just trying to rewrite it as VW by Vs into this Vs in the denominator term, whatever we have the ratio Vv by Vs. If I try to rewrite it, I'll be writing it as Vs by Vv. This is how my expression gets rewritten. Now, if you can look at here to recall, have you come across any of those terms with regard to those which I have indicated here? We have seen what is meant by void ratio earlier, where void ratio was defined as volume of voids to that of your volume of solids. But here, what I have here is the inverse of void ratio term. So then what I can do is, I can rewrite it as, okay, VW by Vs into 1 by E. So simply I am replacing Vs by Vv as 1 by E. Okay. So next, what I'll try to do is, I'll try to rewrite my other terms also to get a relationship between, because I wanted my expression or a relationship in terms of what is called as void ratio, water content, degree of saturation, and the specific gravity of soil solids. I don't want the other terms to be remaining in that expression. So in the process, how do I rewrite it or modify them? Volume is what I can write it as. Earlier we have seen unit weight is nothing but weight by volume. So from this, I'll say that volume is nothing but weight by unit weight. So I'll just try to rewrite according to my convenience and requirement now. Now, which volume am I talking about in the numerator? It is the volume of water. So when I am talking about volume of water is nothing but I can write it as weight of water divided by unit weight of water. Further divided by volume of solids is what I can write it as weight of solids divided by unit weight of soil solids into 1 by E, which is already there. Now I am going to be rearranging my terms like weight of water divided by weight of solids into gamma S, which is there in the denominator, goes to the numerator. Then how it gets rearranged is gamma S by gamma W into 1 by E. What is weight of water by weight of solids? Weight of water by weight of solids is what we have as water content into unit weight of soil solids by unit weight of water is what we have it as specific gravity of soil solids into 1 by E. So is what I am having it as divided by E. So degree of saturation is what I can write it as water content into specific gravity of soil solids divided by void ratio. So if water content, specific gravity of soil solids, and the void ratio of the soil is known, then I can determine degree of saturation. Or if some other parameters are known, the unknown parameter can be calculated from this particular relation. This is how we go on to derive some of those basic relations between various physical parameters with regard to a soil. In the same way, let's go on to see another relationship, how we can go on to derive between the parameters dry unit weight of the soil, specific gravity of soil solids, and the void ratio of the soil. A relation I want to develop between these parameters. So in the process, if I want to develop a relationship between these parameters, so let me understand that dry unit weight is nothing but it's the dry weight of the soil, which we write it as weight of soil solids, divided by the total volume of the soil. Earlier we have seen the expression for what is dry unit weight represented as weight of soil solids by the total volume of the soil. Now, when I am talking about what is meant by total volume of the soil, how do we write down what is the total volume of the soil? The total volume of the soil is nothing but it is a volume occupied by the solid particles plus volume occupied by a void spaces. Now, if I can just try to understand how to rewrite this volume of voids in terms of volume of solids. Okay, so what I'll just try to do is, okay, volume of solids plus volume of voids is what I am trying to rewrite in terms of your volume of solids. So volume of voids, how to write down in terms of volume of solids, if I just want to understand. Earlier we have seen a term which is defined in terms of volume of voids to volume of solids. That's nothing but void ratio. So void ratio is what we define it as, volume of voids to that of your volume of solids. So from this, substituting that here, I understand that volume of voids can be replaced as E into volume of solids. So I can take volume of solids common, and this comes out to be Vs into 1 plus E is what I can write it as here, total volume of the soil. So I am just trying to rewrite my terms according to my necessity, because I wanted to represent gamma D in terms of your specific gravity of soil solids and the void ratio term by replacing all the other terms in which I am not interested in looking at. So so Ws is the weight of the soil solids divided by the total volume is what I have as Vs into 1 plus E. Now, weight of soil solids by volume of soil solids is what I can write it as your unit weight of soil solids is divided by 1 plus E. But what is the relation that I am interested in looking at? The relation should be in terms of gamma D, Gs and E. But what I have here is gamma D, gamma S and E. That is not what I am interested in looking at. Then I have to rewrite further to derive an expression between gamma D, Gs and E. So for that, what I'll just try to do is, I'll try to recall to understand that specific gravity of soil solids, we have defined it as unit weight of soil solids to that of your unit weight of water. From this, unit weight of soil solids is what I can write it as Gs into gamma W. So I'll just go back to my expression to substitute gamma S is equal to Gs into gamma W by 1 plus E. Okay, so therefore I can say my gamma D is what I have represented in terms of your specific gravity of soil solids and the void ratio of that particular soil. And I also have my expression in terms of unit weight also, because unit weight is a standard value where the unit weight of water is what we represent it as 9.81 kilonewton per meter cube. It's not an unknown parameter, it's a known standard value. Okay, so that's how you have developed a relationship between gamma D, specific gravity of soil solids, and the void ratio. In a similar way, I can also go on to see how to develop a relationship between your bulk unit weight or total unit weight of the soil and your dry unit weight of the soil and the corresponding water content that is present in that particular soil. Okay, so to talk about, you find various relationship between various parameters. Just to give you an idea like how to derive them, I'm trying to talk about some of the couple of relations that we most commonly come across with. So for this, what I'll start with is I know how to define my bulk unit weight, where bulk unit weight is nothing but your weight of the soil. It's the total weight of the soil by total volume of the soil. In bulk state, that's nothing but the partially saturated state. What is the weight? So weight, total weight of the soil is what I can write it as weight of soil solids plus weight of water, which is occupying those partial void spaces, divided by the total volume of soil. Total volume of soil, earlier itself we have seen, it can also be represented as volume of soil solids into 1 plus E. So I am replacing your total volume of soil as Vs into 1 plus E. Now further, what I'll just try to do is, I'll take Ws common from the numerator term. So if I take Ws common from the numerator term, what I'll have is 1 plus WW by WS total divided by Vs into 1 plus E. So now what I am getting here is gamma B is equal to, what is Ws by Vs? Weight of soil solids by volume of soil solids is nothing but the unit weight of your soil solids into 1 plus, what is weight of water by weight of soil solids? It's nothing but it is your water content is total divided by 1 plus E. But what I wanted to derive is a relationship between gamma B, gamma D and Wc. That's the water content. But what I have is in between gamma B, void ratio term is there, water content is there, and gamma S is there. So I'll try to rewrite it according to my requirement or according to our necessity. Okay. So my gamma S, if I can recall again, earlier we said specific gravity of soil solids is nothing but is what I can write it as gamma S by gamma W. So this implies gamma S, I'll try to rewrite it as GS into gamma W. So in the process, if I am just trying to rewrite your gamma S as GS into gamma W, so this is nothing but GS into gamma W divided by 1 plus E. This is what I'll try to have it as one term into 1 plus Wc, that's the water content, 1 plus water content. GS into gamma W by 1 plus E is what we have represented or earlier derived it as gamma D. So this is nothing but ultimately what I am getting here is gamma B is equal to gamma D into 1 plus water content. So if I know the dry unit weight of the soil and the water content of that particular soil, then for that corresponding water content, how much is going to be the bulk unit weight of the soil? I can go on to find out. Or if I know the bulk unit weight of the soil and the amount of water content that is present in the soil, I can go on to determine how much is going to be the dry unit weight of the soil. In case if that particular soil becomes dry, what is going to be the dry unit weight of the soil? So likewise, I can go on to find out from the known data, I can go on to find out the unknown data with regard to that particular soil. And in the same way, I can further go on to find out like a relation, not just only in terms of what I have represented as in terms of bulk unit weight, dry unit weight, and water content. I can also further go on to rewrite those terms according to the necessity and derive the other parameters. Like say, if I wanted to derive a relationship between bulk unit weight, okay, your void ratio, specific gravity of soil solids, and degree of saturation. Likewise, if I want, I can go on to still do that. How can I do that? So what I'll just try to do is earlier expression, I'll just try to go back and rewrite it. Gamma B is nothing but GS into gamma W by 1 plus E. Okay, this into 1 plus water content. So where we know that water content is what I can write it as E into S by GS. Just I am trying to rewrite water content is I am just trying to rewrite in terms of your void ratio, degree of saturation, and specific gravity of soil solids. If I do that, what I'll be getting is GS into gamma W by 1 plus E into 1 plus water content is what I am writing it as E into S by GS. So let me rewrite it so that what I'll have is GS into gamma W by 1 plus E into GS plus E into S, this total divided by GS. GS gets cancelled. Now what I'll have is GS plus E into S into gamma W by 1 plus E. That's the bulk unit weight of the soil. This is the relation what I have. In case if I want to find out what is my saturated unit weight in terms of the same other parameters like your specific gravity of soil solids, void ratio, if I want to derive a relation for what is meant by saturated unit weight of the soil. So for saturated soil, if I am looking at, my degree of saturation value is nothing but it is equal to 1. If the degree of saturation of the soil is nothing but it is equal to 1, then that particular unit weight becomes, it is the saturated unit weight, because once all the voids are filled by water, then we are saying degree of saturation is nothing but 1. If the degree of saturation of the soil is 1, then corresponding unit weight of that soil, I should be calling it as saturated unit weight. So in the above expression, if I substitute a degree of saturation value is equal to 1, then what I'll have is specific gravity of soil solids plus E into 1, which is, in fact, I can write it as simply E divided by 1 plus E into gamma W. So if I know the specific gravity of soil solids and if I know the void ratio of that particular soil, and if it is given the soil is a fully saturated one, I can go on to find out the saturated unit weight of that particular soil. In the same way, if I want to find out for that particular soil, if in a dry state, what is going to be the unit weight of that soil if I want to find out. So once we say if it is a dry soil for which we are trying to talk about the unit weight, so for that particular soil, if it is in a dry state, then the degree of saturation value is nothing but it is equal to 0. Then if the degree of saturation value is nothing but equal to 0, then this particular expression, how is it going to get modified? So if S is equal to 0, then automatically the unit weight, what I am going to be talking about is what is to be called as dry unit weight of that particular soil. So which we write it as GS plus E into 0 by 1 plus E, this total into gamma W. This is what we have it as. E into 0 is nothing but 0, is what we'll be once again getting it as GS into gamma W by 1 plus E. This is the expression which we have already derived previously. So that's how we go on to derive the relation between various parameters, various terms that we are interested in looking at. Okay. So for deriving these various relationships that we are going to be coming across with, whatever I have shown you here is not everything, and it's not that all those relations we have touched upon here. Just to give you an idea of how to derive those relationships between various parameters, we have touched upon some of those relations only. But however, we have got two different approaches or methods by which one can go on to find out the various relationships between those different physical parameters that we have come across with. Okay, so those basic relationships, what we are talking about, the different basic relationships between different physical parameters with regard to a soil can be derived based on two approaches. One is by what is called as specific volume approach, and the other one is what is called as unit volume approach. Now, what is the difference between this specific volume approach and unit volume approach? In the case of specific volume approach, what we assume is volume of soil solids present in a given volume of soil to be equal to 1. For unit volume of soil solids, based on that consideration, we go on to derive that relation. Coming to the other case, that is unit volume approach. In the case of unit volume approach, what we assume is the total volume of the soil is equal to 1. For a unit volume of the soil, within a unit volume of soil, how much is the volume of solid particles, how much is the volume of void spaces. Based on that, we'll go on to understand how to derive the relation between those various physical parameters with regard to that particular soil. Okay. Just to give you an idea, again, some of those relations which I have earlier derived, those one or two of them, we'll try to once again look at to get an idea of how to derive those relations again in between those various parameters. That it could be in terms of your dry unit weight, how do I get those expression based on your specific volume approach, or maybe by unit volume approach. Whichever approach you follow, it doesn't matter. The relationship what you are going to be deriving comes out to be the same. In some cases, the relationships can be easily derived based on specific volume approach. In some cases, it is going to be easily derived based on your unit volume approach. Otherwise, it doesn't matter which approach you follow, you will be still getting the same basic relationships which we are going to be getting either by following the first approach or by the second approach. See, either in the case of specific volume approach or unit volume approach, by looking at your phase diagram only, we'll be easily able to understand how to calculate or how to build that relation between those different parameters what we are talking about. Let's say I'll go by what is called as your specific volume approach, just for our idea, like based on this particular approach, how do we derive the relation between let's say the dry unit weight, specific gravity of soil solids, and the void ratio terms. Earlier, whatever we have seen. Once again, I'll just try to derive it again, but based on what is called a specific volume approach. Once I say specific volume approach, we assume that the volume of soil solids is nothing but it is equal to 1. Now, let's say, for example, I'll be looking at my phase diagram. This is my three-phase diagram of that particular soil, where I am indicating my solid phase, water phase, that is indicating your liquid, and your gaseous phase, which is represented by air. This is what we are indicating it as volume of solids. This is what we are indicating it as your volume of water, and this volume is indicated as volume of air. So volume of air plus volume of water both put together is what we call it as your volume of voids. So volume of voids plus volume of solids total put together is what we call it as the total volume of your soil. Okay. So in this specific volume approach, what is that we are assuming? Volume of solids is equal to 1. So if volume of solids is equal to 1, then how can I write my total volume as? Total volume is nothing but it is equal to volume of solids plus volume of voids. So volume of solids is what I am writing it as 1 plus volume of voids is also what I can rewrite in terms of your void ratio and volume of solids earlier, which we have seen. So where volume of voids is what I can write it as volume of solids into the void ratio. And volume of solids is once again, which I can substitute it as 1. Okay. So therefore, what is going to happen is your total volume of the soil is what I can write it as 1 plus E. The total volume of the soil is what I am writing in terms of 1 plus E. Generally, what happens earlier, we have seen total volume is what we have represented it as Vs into 1 plus E, where Vs is considered as 1, automatically the total volume is nothing but it is equal to 1 plus E, according to this specific volume approach. So let's say now in dry condition of the soil, because I am interested in deriving a relationship between gamma D, specific gravity of soil solids, and void ratio. So I have to consider the dry condition of the soil. In the case if it is a dry condition of the soil, then my three-phase diagram becomes the two-phase diagram, where all the voids are going to be represented by air only. So what we'll have is a solid phase, and the other is your air phase. So this is your volume of solids, and this volume occupied by air itself is what I can indicate it as volume of voids. That's how what we can write it. And in terms of weight scale, if I am looking at, this is what we indicate it as weight of the soil solids, and this is indicated as weight of air, which is nothing but approximately we consider it as 0. Okay. So according to this specific volume approach, as we are saying the volume of soil solids is nothing but we consider it as equal to 1, then I can go on to understand how to derive that relationship between the dry unit weight of the soil, specific gravity of soil solids, and the void ratio of the soil. So for that, what I'll try to define is what is meant by dry unit weight of the soil. So how do we define the dry unit weight of the soil? Dry unit weight of the soil is nothing but it's the weight of the dry soil, which we write it as the weight of soil solids by volume, the total volume of the soil. Now, what is my weight of the soil solids can be represented as weight of the soil solids. I'll just try to rewrite. Look at here. I'll come from your specific gravity of soil solids expression, where specific gravity of soil solids is what we represented as unit weight of soil solids by unit weight of water. So unit weight of soil solids is what I further rewrite it as weight of soil solids divided by volume of soil solids is what I am writing it as unit weight of soil solids divided by gamma W, as it is I am trying to write it. So from this I am trying to write down what is WS. WS is what I can get it as GS into gamma W into VS. Okay, that is what is nothing but it is the weight of soil solids is what I can write it as GS into gamma W into VS. But according to specific volume approach, we are saying that your volume of soil solids is nothing but equal to 1. Therefore, WS is nothing but it is equal to GS into gamma W. So, WS I can replace it as GS into gamma W. And total weight of the soil is what I can write it as 1 plus E, which we have seen in our previous slide. So, weight of soil solids is GS into gamma W divided by total weight of the, total volume of the soil is what I am writing it as 1 plus E. This is the relation what we have earlier also derived. So, based on specific volume approach, we are easily able to derive what is the dry unit weight of your soil. In simple way, we are able to derive it. In the similar way, you can also go on to derive the relation with regard to your saturated unit weight of the soil also. Earlier we have seen that saturated unit weight is equal to GS plus E by 1 plus E into gamma W. That relation also you can derive. Or partially saturated unit weight expression also you can go on to derive further. Okay, just for your idea again, if at all you are interested in deriving the relation in terms of that. So what I'll understand is, in case if the soil is a saturated soil, then my phase diagram gets modified into a two-phase diagram again, where the volume of voids is nothing but it is equal to volume occupied by a water. So from that basic fundamentals, again we go on to write down what is my expression for gamma sat. That's the saturated unit weight of the soil, which we write it as the total weight of the soil by total volume of the soil. Now, what is my total weight of the soil? It is nothing but weight of soil solids plus weight of water divided by the total volume of the soil, which in turn what we can write it as 1 plus E. Now, what is your weight of soil solids equal to? I can write it as GS into gamma W into Vs, where Vs is nothing but equal to 1 according to specific volume approach. And weight of water. Weight of water is once again what I can write it as. Okay, let's quickly look at here. This I'm just trying to rewrite it. Weight of solids plus weight of water is what I am writing it as water content into weight of solids divided by 1 plus E. And where Ws I can take it common into 1 plus WC, this divided by 1 plus E. Where WC, that's nothing but water content, I can try to rewrite it in terms of your degree of saturation, your specific gravity of soil solids, and the void ratio, which we have seen earlier. Okay, so in same way, I can go on to replace your water content. Okay, so E is in E into SR divided by GS is what I can write it as your water content, replace it, and weight of soil solids is what I can write it as GS into gamma W. So upon rewriting and readjusting your terms, you'll be getting your expression for your saturated unit weight in terms of your specific gravity of soil solids and your void ratio, and subsequently the degree of saturation and so on. So I can rewrite my expression, and upon substituting the term Ws as GS into gamma W, water content is equal to E into GS by SR. So I'll be getting my expression for gamma sat is equal to GS plus E into S divided by 1 plus E into gamma W. As the soil is saturated, obviously your degree of saturation value S is nothing but it is equal to 1. So my expression is ultimately going to be GS plus E by 1 plus E into gamma W. In case if the soil is a partially saturated soil, then instead of writing it as saturated unit weight, I'll be writing it as bulk unit weight. So bulk unit weight is nothing but GS plus E into S by 1 plus E into gamma W. So which approach you follow, it doesn't matter. Ultimately, you will be able to derive the relation between various parameters that you are interested in looking at in order to find out some unknown values with regard to the soil from the known data that is given in the problem with regard to a soil. So what is that on a whole we try to understand here is, any of those basic relations that we are interested in looking at can be easily derived by making use of your simple phase diagram. You are not required to memorize or remember those relations what you have between various parameters. Okay, so you need not remember all those formulas that you have got which are said to be the relationship between various parameters. Okay, so if at all required, you can go on to derive any of those relations by either simple relations that you have got between them from the basic fundamentals you can start with, or by making use of your phase diagram also, that is based on your specific volume approach, or by your unit weight approach or unit volume approach, sorry. You can go on to derive those relationships between different physical parameters with regard to a soil. Okay, so for deriving those relations, don't mug up those relations. Rather, what you need to do is, you should know the basic definitions of various physical properties that we are going to be talking with regard to the soil, like void ratio or water content or degree of saturation or porosity or air content or air void ratio, like all those physical properties that we have talked about with regard to the soil, or unit weight. Okay, so we should know how to define them first, and by looking at your phase diagrams and by considering either your specific volume approach or your total volume approach, you can go on to derive those relations. And you will find in any of the standard textbook or any literature that you refer to, you will be finding various relationships, something what are listed in this particular slide, that which relationship that I should be using for finding out the unknown with regard to a particular soil. If I need to know, first let us understand what is the data given there with regard to a soil. Let's say, for example, if the water content present in the soil is given, if the specific gravity of the soil solids is given, if the void ratio of the soil is given, and if you are asked to find out what is the bulk unit weight of the soil or moist unit weight of that soil, or if you are given with the unit weight of bulk unit weight of the soil and water content is given, you are asked to calculate the dry unit weight. So which expression I should make use of? Or if the specific gravity of the soil solids data is given, void ratio is given, I am asked to calculate the dry unit weight. So depending on what data given to you, what is the unknown that you are interested in calculating, so you have to look for that corresponding data given and the corresponding unknown what you are required to calculate. Let's say, for example, I want to calculate the dry unit weight of a soil. For calculating the dry unit weight of the soil, what data I know? Do I know the bulk unit weight of the soil and water content? Or do I know the specific gravity of the soil solids and the void ratio of that soil? Or do I know the specific gravity of the soil solids and the porosity value of the soil? Or do I know the specific gravity of the soil solids and water content and degree of saturation of that particular soil? So based on what data you know, you will be using the corresponding relation to find out your dry unit weight of the soil. Likewise, any expression, any unknown parameter with regard to the soil, if you want to find out, only simple things what we need to know is, what is the data given with regard to that particular soil? What information you know with regard to that soil? And what is that you wanted to find out? So from that known information, to find out the unknown, what relation you have got between those parameters? You should look at it and accordingly use it to find out the unknown. So all those relations that are listed here can be derived. It's not that you cannot derive them. It can be derived by making use of any of those approaches, and you can develop that relationship between various parameters which are listed here. So having understood how to derive those relationships between various parameters with regard to the soil, let's go on to take up some problems to find out some unknowns with regard to a soil based on some known data about that particular soil. Okay. So what is that we know about this particular soil? What is given in the problem? Let's look at here. An undisturbed sample of saturated clay, the soil is said to be saturated, has been found to have a water content of 24%. So that saturated clay soil has got the water content value. Either you can write it as WC, or you can simply also write it as small w. So the water content present in that particular saturated clay soil is nothing but 24%. The water content of that soil is 24%. The specific gravity of the soil solids is given as 2.7. So for that saturated clay, when the specific gravity value of the soil solid particles is determined, the value was found to be 2.7. Now we are asked to calculate what is your void ratio of that particular soil and the bulk unit weight of the soil. Void ratio is an unknown which I wanted to find out, and bulk unit weight is the other unknown which I am required to find out. So for finding out void ratio, what data I know? So what data is known to us is water content of the soil is known. Soil is said to be saturated clay. Once we say the soil to be saturated clay, then the degree of saturation value of that particular soil is nothing but it is equal to 1. So water content of that soil is known, degree of saturation value of that soil is known, specific gravity of the soil solids is known. Then void ratio is what I can determine from that relation what we have seen earlier, E is equal to W into GS by S, where water content is 24%. In terms of fraction, if I write it, it's nothing but 0.24 into specific gravity of soil solids is what is given as 2.7 divided by degree of saturation, as the soil is a fully saturated soil, saturated clay. So as the soil is said to be saturated, so degree of saturation is nothing but equal to 1. So if I go on to calculate what is the void ratio of this particular soil, I'll be getting the value to be 0.648. Or I can also write it in terms of your percentage, where it can be indicated as 64.8 percentage. So this is how I can find out the void ratio of that particular soil, which has got water content equal to 24%, specific gravity of soil solids equal to 2.7, and the degree of saturation value of that particular soil is equal to 1. And what is the other unknown that I want to find out? The bulk unit weight of the soil. As the soil is said to be fully saturated, then what is that unit weight that I am going to be talking about? Though I call it as bulk unit weight, then it's nothing but we indicate it as here saturated unit weight of the soil is what in fact we are trying to calculate, because the soil is in a saturated condition. So the saturated unit weight is what I can write it as GS plus E into S by 1 plus E into gamma W. I am using this relationship because I know what is the specific gravity of soil solids, I know the void ratio of the soil, I know the degree of saturation value of that soil. Okay, unit weight of water is anyhow a standard value, so I can make use of that data and I can go on to substitute into this expression. GS is nothing but 2.7 plus void ratio value of this particular soil is 0.648 into the degree of saturation of this saturated soil is 1. So this total divided by 1 plus 0.648, this total into the unit weight of water, which is a standard value, that is nothing but 9.81 kilonewton per meter cube. If nothing specified with regard to the unit weight of water in the problem, then you have to compulsorily consider the standard value, that is here 9.81 kilonewton per meter cube. Sometimes what happens is in the problem you are given with gamma W is equal to 10 kilonewton per meter cube. You will be said, assume gamma W is equal to 10 kilonewton per meter cube. So in such particular case, you can consider gamma W is equal to 10 kilonewton per meter cube. But otherwise, if nothing specified, you have to take your standard value. So upon substituting all this data, we will be getting your saturated unit weight of the soil as 19.93 kilonewton per meter cube. So that's how, depending on the data what is given with regard to a soil, we can go on to find out the other unknown information with regard to that particular soil. Okay, so we'll stop our discussion for today with this, and in the next class we'll continue our discussion with some other couple of problems where we can see how to find out some unknown information with regard to the soil based on the known data what is available with us.